about the time value of money. It won't be wrong if. Good morning, everyone. This is Harshad Bajpayee, and today we are going to discuss about the time value of money. It won't be wrong if I say that the value of money, in a sense, is a function of time. Also, we can say that the same value of money would be different at the end of first year, at the end of the second year, and also at the end of the third year. The money is essentially the same, but as the time span is changing, the value of money is also changing. Now let us explore the reasons for the existence of time value of money. If I say that a rupee today is more than a rupee tomorrow, then what goes behind my saying that a rupee today is more than a rupee tomorrow? Primarily, there are basically four variables or four factors which, in a sense, are responsible for the relationship that the rupee today is more than a rupee tomorrow. Let us see what are these. The first reason is investment. If I get the money today, I can invest it and earn returns on it. Therefore, I would like to prefer the money today. The second reason is inflation. So what is inflation doing? Inflation is eroding my money's value. Therefore, the same money tomorrow will be less because of the presence of inflation. Ergo, I would like to prefer the money today. The third reason is present consumption. Because of my consumption needs today and I have to meet them, therefore if you are giving me money tomorrow, I'll have to forsake my present consumption, which I don't want. Therefore the money today is worth more to me because I can consume things there and comparing it with the rupee that I will get tomorrow. So the preference for present consumption is the third factor which is in this equation. The fourth factor that influences this equation is the risk. Due to risk, because as the time span is increasing, the uncertainty is also increasing. The macroeconomic situation will also change. Therefore, I am accounting the risk into the equation and saying that I would rather prefer money today than money tomorrow, because the later I get the money, the more risk is involved. Hence, these are the four reasons which go behind the equation. And when I say that a rupee today is more than a rupee tomorrow. Keeping all these factors in view, if I'm saying that I'm okay with you giving me money tomorrow, then it implicitly means that you must compensate me for all these four factors. That is, you invest my compensating elsewhere, you compensate me for the inflation, you compensate me enough that I forsake the present consumption, and you compensate me enough that the risk is proportional. So, all these factors need to be compensated. And when I say that this is still qualitative, converting into quantitative terms, it just becomes a number. Required rate of return, or we can say interest rate. That's all, that's what is the time value of money. We combine all these factors, the compensation for all these factors, it summarizes into a single number, which we can say interest rate or the required rate of return. The common way of saying when we talk about interest rate, it basically means the nominal interest rate. Now, the nominal interest rate has two parts. One part is the inflation. The other part is the real interest rate, which is nothing but the compensation for forsaking the present consumption. So nominal interest rate we talk about when we get from banks has two parts: inflation and the real interest rate. Now this is considering the fact that the risk is not involved, the investment's returns are guaranteed. When I'm investing in an asset, I would like to know what should be my required rate of return. The required rate of return will have two components. The first component is a risk-free rate. That is when we invest in government securities where there is no credit risk or there is no default risk. The other component is the risk premium. That is when I'm investing in an asset, I'm taking risk and I must be compensated for taking that risk. So the required rate of return will have two components: the risk-free rate plus the risk premium. The reason why we are discussing all these rates here is because we want to make decisions, and in those decisions it is very important that we take the time value of money into consideration. One of the most important and most significant domains wherein decisions are taken is capital budgeting. So in capital budgeting, what happens? In capital budgeting, there are projects A, B, C, D. Each will have its own life. Maybe A will have 4 years, C will have 2 years, D will have 10 years, A might have 1 year. Now, how do we compare all these projects with different life? Because they will have cash flows. A will have cash flows in year 1, 2, 3, 4. C, B, D, every will have cash flows. But you cannot compare each of the cash flows directly, because a cash flow at the end of 10th year might not be equal to cash flow, or what is not equal to cash flow at the end of the first year. Hence, we need to reduce them and account for time value of money. So we need to compare cash flows from all walks of the business. You might have cash flows at say 10 years, cash flows at 5 years, cash flows even 6 months. So from different ways, receivables, you might get cash from, and etc. To make the correct decisions, we need to account correctly and reduce them to the present time zone. This is the most important. Once we get their value, their present value, then and then only we can compare them and will be able to take the correct decision. The time value of money works two ways. First is we can calculate a future value. From present value, we can calculate the future value. This technique is called compounding. And when we'll calculate the present value from the future to the present, we call it discounting. Now, but there is a rate at which this is done. When we compound it at a rate. When we discount it at a rate. That rate is called as, we do this at a rate called as discount rate. Now this discount rate compensates us for time value of money, which in turn includes the risk. Therefore, the project which will have a higher risk will also have a higher discount rate. Let us see now how compounding and discounting works. So first, let us see how does compounding work. The formula for the future value is A, that is the amount which needs to be compounded, multiplied by one side of the power n. N stands for number of years. I is the discounting rate or the compounding rate which we are going to use. So the present value we can calculate, that is present value is equal to A upon 1 plus I to the power n. I is the discount rate. Now we simply put the formulas and we get the present values and the future values. Now in this formula, this part is, and also and this part which excludes the A. This part and this part you can get from the table. So you can get this part directly from the table, so you need not use the calculator every time, but you need to have the time value of money table with you. Now let us understand this by an illustration. What we need to calculate is the value of our investment at the end of 5th year. We can see that at the end of every year we are investing some amount. Now what we want to know is that at the end of the 5th year, what is the future value of all our investments. So for what we first need to know is, first is the amount. We know that 500, 1000 and so on. Second thing which we need to calculate is the years compounded. Because it is at the end of the first year, at the end of 5th year, the first amount, that is 500, would be compounded 4 times, and subsequently each amount would be compounded accordingly. Now by using the formula we can get the factor, compound interest factor, or we can directly see it from the table. Once we multiply 500 with the factor, we get this amount. Similarly, when we do this for each, we get the future value, and when we will sum it, we get the total amount or the value for investments at the end of the 5th year. Let us look closely at the cash flows listed here. We can see that at the end of the first year we have 2000, at the end of second year we have 2000, third, fourth, fifth, sixth, we have 2000 rupees deposited at the end of each year. Now when we have such kind of cash flows which are equal, we call them annuity. So we have annuity, which is nothing but equal cash flows. The second thing to be noted here is that we can calculate the future value of an annuity directly using a formula. Okay, or we can go in the long way. We can calculate for each year the compounding factor, like this, then multiply, and then we get the future value of the annuity. Or alternatively, we can, from the table, we can directly see the value of the compounding factor, that is here it is 6.82, directly from the table. We can also use a formula likewise if we used for compounding and discounting. We can similarly use a formula for annuity. Now as we need to calculate the future value, here we can get this value 6.82 using the formula for future value. Alternatively, we can get it from the table, and the value comes out to be 13,604. This is the annuity value formula. This is for calculating the future value of an annuity. F is the future value, A is the amount, I is the discounting rate, N is the number of years compounded. An important application of the time value of money is sinking fund. So a sinking fund is nothing but a fund which is created out of regular equal payments to meet a specific demand in future. Suppose that we want to need an amount of say 1 lakh at the end of say 10 years. So sinking fund is a fund wherein each year you would put a certain amount, so that at the end of the period we get the 1 lakh rupees you need. This regular fund is called as a sinking fund, a fund which is created to meet a specific future need. The calculation of this 1 lakh, in this case of fund, the regular annuity, is very easy, because these are equal amounts, say A, each year, and hence it becomes an annuity. So we can use the formula for an annuity. We deposit an amount A, the future value is 1 lakh. We can now calculate the value of A. It's just an annuity. We've talked enough about compounding. Let's also talk about discounting. Now you see that When we calculate the future value, we call it as compounding, but when we calculate the present value, the opposite, we call it as the process called as discounting. Now when we talk about the project will have many cash flows. If it's a 10-year project, it will have 10 cash flows, the annual cash flows. So when we calculate the present value for so many cash flows, we do it this way. So in this formula you can see that present value is equal to C1, C2, C1, C2, and Cn, they are basically cash flows, and C1 is the cash flow at the end of first year, C2 is the cash flow at the end of second year, Cn is the cash flow at the end of the nth year. So according to the present value formula, we can calculate the present value of a series of cash flow. If these C1 and C2 and Cn were equal, we would call this as an annuity. So the present value formula for an annuity we can use. We have already used the future value formula for an annuity. We will also see the present value formula for an annuity. So when we need to calculate the present value for an annuity, we need not do it the long way. We calculate the present value for each year, sum them up. No. We can directly use the formula as given here and directly calculate the present value of an annuity. Alternatively, we can use the table. For calculation of the present value. Perpetuity, which is nothing but the annuity which goes on forever or has an infinite life. The present value of that perpetuity is equal to A, the amount per year, upon I. I is the discount factor. That's about perpetuity. Let's look into another important concept that is called as annuity due. Till now we've talked about annuity. That annuity, the cash flows were coming at the end of the year. But in annuity due, the cash flows start from beginning of the year. This is basically generally the case wherein we buy things, for example, on installment. So we pay in the beginning of the year. So let us see what are the future values in case of annuity due, because it would be different from the traditional annuity which we have talked about. The formulas are very simple. The future value of an annuity due is nothing but the value of an annuity into 1 plus I. And similarly for the present value, it's present value into 1 plus I. This is because the annuities are getting compounded or discounted for one more year. That's why. Till now, whatever you talked about, there was an implicit assumption in those, and that was that the compounding is done on an annual basis. So what happens when the compounding is done on an annual basis, it is like this. In time 0 you invest. At the end of the first year you get the amount plus the interest, and on which again the compounding happens. Okay, so at the end of the second year you basically get an amount which is nothing but the amount plus interest into 1 plus I. In simple compounding, it's not like this. It's the interest is fixed, so it does not add on top of the A. That is why simple interest, the interest amount is lower. When you talk about compounding, the compounding is done on the sum which is at the end of the year. That's how the compounding works. Now, what do you mean the frequency of compounding? It can also happen that at the end of the first year, instead of the compounding being done at the end of the year, it can also be done at the end of 6 months. So now what happens? The interest that you get from 6 months, let us say it's A plus I6, the interest on 6 months. Let us do it differently. So let's see again, we get some interest at the end of 6 months. Let's call it as the original amount plus I, which is at the end of the 6th year. Now even the compounding is done on a 6 monthly basis. At the end of 6th year, the amount that you have is I plus 6i. Then again it will be further compounded for 6 months. So when the frequency of compounding is 2 times in a year, so the interest that you will get will be more, because for 6 months you are being compounded on a larger sum, that is a plus I6. So at the end of the first year, the amount that you will get will be much more than the amount which you've gotten on annual compounding. So let us see that when the compounding is done 4 times in a year or every 3 months, so we have the amount A plus some additional amount, which is the interest. On this again the interest would be calculated, so we get a further more amount, let's say 2 delta, then again a further more amount, and then again a more amount. So at the end of first year, when you do it 3 monthly, it will be more than when you do it 6 monthly, and it will be more, even more for when you do once in a year. This is how compounding works and the frequency involved here. Hence, when the frequency of compounding is more, the future value or the interest that you are getting will be definitely be much more. There are few more things that we need to consider here. Suppose you are getting 12% for an year, that was your interest rate. Now when you are doing compounding 6 monthly, the interest that you are going to use will be 6% in your formula when you calculate. If you are doing it say 4 times in a year, which is quarterly, then your interest should be 3%. The total comes out to be 12, but we will not use 12% for the small, because this 12% is spread out across the year. If you are doing it say monthly, then it will be 1% in the formula in which you will use. Now let's see what is the formula. This is the formula for multi-period compounding. The future value, if you just put n is equal to 1, then if you put m is equal to 1, then you get simply the formula, the traditional formula that we will discuss in case of the future value. But when we are multi-period compounding, we divide I by m and then multiply m with n. M is the frequency of compounding. If the compounding is happening say 6 monthly, then how many times in a year we are doing the compounding? 2. So m becomes 2. If you are doing 3 monthly, then how many times in the year we are doing 4. Hence m becomes 4. Or as we have seen in the last slide, it's a similar thing. Here we divide I by m. So if I was 12, we divided by m, which is equal to 6, and m was 4, 3 monthly, we divided by 4, it comes out to be 3. As you've seen in the last slide, this 3%, 6%, it is the same case, but it's the formula, more systematic. Now when we multiply m with n, then we get the number of the total number of compounding periods. Like if you're doing 2 times in a year, then how many times you're doing it in 10 years? So 2 into 10, that's equal to 20. That's how it simply works. This is the future value in case of compounding. Now when in case of multi-period compounding, we have to calculate present values and future values for annuity and other things. If you go by formula, the formulas are very complicated. So alternatively, what we can do is, in the table as we have the discounting factor as well as the number of years. These are the years down, and this is the discount rate that which we are using now. In order to avoid complicated formulas, what we will use is, we'll use the new I and the new year. Instead of year, which is number of years, we'll use the compounding period, which is nothing but mn. And instead of using discount rate, we will use discount rate which is applicable to the compounding period, which is I by n. So for example, if we had 12% and say 3 years, and the frequency of compounding was 6 monthly. Now what will happen here? In the table we will see, instead of saying 12%, we will see how many times I by m. M is, since it is 6 monthly, so m becomes 2. So I by m equals 6%. So 1, 2, 3, 4, 5, 6, 7, 8. So this is our interest. Now in the year zone, mn, m is 2, n is 3. So the number of years compounded is 6. So in the year zone we will see 1, 2, 3, 4, 5, 6, 7. So here we will match them, and the compounding factor which we get here, we can use it in case of multi-period compounding. Simple. There is one more type of compounding that is called as continuous. And the formula for the future value is equal to a into e to the power I n. E is the exponential, I is the discount rate, n is the number of years that we are using. So future value is equal to a into e to the power I n. Normally we get cheated when we are taking a loan, because when the loan people tell you about the interest, basically the interest they quote is say 12%. That is the annual interest rate that they are charging you. But how do you pay? You pay monthly and installments. Hence, you are using monthly compounding here. But they say that they are charging you 12% annually, but in fact they are charging you more. Let us look into this using the previous formula. Suppose that the annual interest rate is 8%. So the effective interest rate would be for 1 year. So mn becomes 12 in case of monthly compounding. So 1 plus 0.08 upon 12 to the power 12. This is equal to 1 plus 0.82, or in a sense, in 1 year my value is compounding more. On one hand, on annual interest I was getting 8%, but because of the monthly compounding I am getting 8.2%. So in fact the people are cheating because of the monthly compounding. So you're in a sense you're paying 8.2%, where you've been said that you are being just charged 8%. We can apply these formulas in real life situations like this. Read the question. It is an interesting case, and kindly solve it. Without seeing the answer, I am also giving you the answer for the question. So now you decide which form of loan you need to go for. So thank you very much for listening to me very patiently. You can email your questions and doubts at my email address. Have a nice day. Thank you.